Today on Captain Castle's Laboratory, we're going to be working on a Ghoulish Gourd from Lemax. This one, the pumpkin here doesn't work right, and there's no sound. So, you can see it's just going back and forth, but it's not spinning around. Also, the lights inside are, well, almost non-existent. I'm covering it so I can see. So, we don't have any rotation. And wheel all the way up. See, I'm moving it back and forth. No noise. Off, on, off, on. So, we're going to have to open this and take a look inside. A suggestion was to start putting these things maybe on a piece of foam. So when I was cleaning out a room from a bursted pipe I just experienced, I found I had a piece of this foam lying around. So we'll put the house on that. Sound. Sound could be broken here in the switch. There's a couple of wires that are in this switch that cause the sound, the wheel to turn it on off your sound. So it could be in the switch. Now the switch feels good. Doesn't mean a wire didn't break. Or it could be down here in the circuitry. The speaker could have unplugged itself, or a wire could have broke, or the speaker could have come desoldered. So there is a sound problem. And then the pumpkin, there is no, like this pumpkin has resistance. I can't lift the top. This has no resistance whatsoever. And now my personal one, it has resistance. This, yeah, you can see it. Nothing. So, we're going to start with the pumpkin, because making it work correctly, we're going to start with the motion versus the sound, and then we'll go into the sound second. Now, this section here, that's the gray that goes around, is glued in, and it should come out if you heat it and pop it free. Blade screwdriver, I'm going to use a spudger, but you can use a blade screwdriver and a hair dryer. I'm going to use a heat pen, of course, because it's part of my station. So we're going to start with this and work our way. And turn on the heat pen. Looking down inside, I see that there's glue here and here, and I have a little bit of glue in this front corner, and that's all I can see. I can see through into the house on either side in the front section. So I'm just going to heat the area that I see the glue first. So I don't want too much of the heat going down inside. Just in case there's something close to the top like a wire. I'm going to heat this side. Hopefully that's enough. We'll see. And I'm going to give credit where credit is due. When this came out, I believe it was last year, somebody else had taken one apart to fix this pumpkin. And if you haven't checked out his YouTube, it is Villages and More. And using his example on how he removed this one is why I'm going to start here with this one and try and pop this corner. So, if you watch all sorts of videos on villaging, check his channel out. I recommend watching most of the villaging channels. That's how I learned some stuff, like how to do platforming by watching Halloween Villages by Carl. Also, Kay's Crafts. Although I'm not near as good as either one of them, but it's still interesting to watch people who are good at their craft do stuff. So, So the temperature did help loosen this piece and some of that. So I'm going to add a little bit more heat and do some more. If you are going to try it with a screwdriver, try and get a narrow one. You can see I'm putting it inside this gap, and it's too thick for this side, but perfect for this side. Just do a little double team or walk around and slowly get it to break free. There we go. So here is the drive mechanism. One thing I will say about this piece is the way they have it compartmentalized. So each section is separate. That's kind of nice. So if you lose a pumpkin, you don't have to necessarily disassemble the whole unit. And just like on Village's and Moore's channel, the circuit boards inside aren't attached, and neither are these. They're just floating in there. That is kind of a really cheesy way of doing things. So if you look inside, see? It's just floating in there. But with the moving parts contained inside of these two, this one has a smaller version of this piece of plastic as an example. That is just freaking hilarious that they would just make it so loose. So this big drive gear is loose. I don't think that's the problem. It's got the impossible gear, which if that is broken in a couple of weeks, I'll have some. So I should be able to hopefully fix this before Halloween. I am going to turn it on. I want to see if this motor spins. So the motor is spinning. Hopefully you can see that in the light. There you go. And all the gears are moving, but it's not touching there. So my problem is the impossible gear is turning, but the big gear isn't. There is a monster of a gap there. So we need to figure out what happened. So first I'm going to do is I'm going to unscrew the eccentric screw for the pumpkin. And next I'm going to unscrew the mounting screws for the drive mechanism. I want to get to that big gear and see if it's broke. Either the gear is just loose or the mounting where the screw goes through has broke. It's hard to tell. Everything's white, so it all blends in, so it's hard to see if anything is out of place. So I just want to get these screws out. There we go. It looks like to remove the pumpkin, you got to unplug it. One plug's really easy, it's right here. So we'll just unplug the shorter wire. There's a pin that's pushed through that this pivots on, right there. And this pin is stopped by this plastic tab. And on this side, it looks like this can come off by lifting that plastic tab. So you need a really small spudger, which I don't think I have one small enough. That's not plastic. So I'm gonna look for a small screwdriver. Like this, a small blade screwdriver. I'm gonna see if I can lift this finger. Got the finger to lift, but she still doesn't want to come apart. They might have glued it. Alright. Let's see if I can get to the screw by going through the center. And we'll see if it screws down, then we know the gear came undone. If it doesn't screw down, then it's broke. It doesn't screw down. So, it's broke. Alright. Let's see. Is there enough flex that I can just flex it out of the way? There is. Alright, so here's the problem. That white piece right there is the plastic casting from right here. So this gear has physically snapped off of the housing. I'm trying to... There we go. There we go. That is why this isn't working. So, I have an idea. You can try and glue this back on, and it may hold for a while. It's going to be under constant tension as this is going back and forth in the eccentric. It's going to be putting a kind of an oval pressure on the shaft. So instead of it just spinning circularly, which it normally would do, because it's in the eccentric, as it spins, it's going to be wobbling, and that's probably what causes the fracture. But with a little modification, you notice the size of that hole, and you notice how small that one is. This screw only purpose is to hold this gear. That's why it's got pan head screw, so it doesn't push through. As long as whatever you put in here is lower than the indentation of the gear, you're fine. So we can replace this with a pan head machine screw and bore out that hole, because this side is recessed, and put a nut. I'd recommend a locking nut, nylon locker, because you can't torque this down, because if you do, gear doesn't spin. Gear doesn't spin, it's absolutely useless. If the gear doesn't spin, then this piece, you're going to snap this gear right here. And right now, they're hard to find. A couple of people are making them, but they're costing $20+ a piece. Again, small price to pay to fix a unit like this, because it's such a nice piece, but it's money you shouldn't have to spend if we can avoid it. So we are going to modify this, and I'll get the parts to do that, and I'll show you how I'm going to do it. So in the meantime, let's try and see if we can figure out the sound. First thing I want to do is get this circuit board that's flopping around in here and see if I can unplug this unit completely, so I can move on to the next project, or the next part of this project. So here is that circuit board. So just like I normally do, to make sure that I keep them the same, I'm going to unplug this module. For the motor, right here. So I can get that out of my way. And now I'm going to try and rotate the circuit board so I can unplug this one. Now this one is the only one in here, at least this one is, this specific house, it has a black plug, so it's going to be kind of hard to screw it up. As you can see, black plug. I cannot believe they just have this circuit board just floating around in here. It's amazing. But let's take a look. Now, one of these two here is the sound chip, the amplifier chip. So I'm going to put on some magnification goggles, and I'm going to take a look at them and see if I can read them. That's your sound chip, this guy. So I'm going to examine the components around it to see if any of them are popped, to see if that's why I don't have a speaker. So those look good, It all technically looks okay. Big capacitor on the front, which is a smoothing capacitor. It looks good. Smoothing capacitor doesn't always mean that there's a problem. If it's popped, it's just a general. Here's the speaker plug. It says on here, it says, these are labeled. Most of them are on these new houses, as much as a lot of people don't like the plastic or resin style. But this is M1. M1, M2, M2. M means motor. So if you have a house that's not working, most likely it's a shorted motor, and it has the Molex connectors, unplug the ones that say motor and see if your lights and sound come back. Most likely, they will. Your big incoming power for this is this multi-colored, multi-pin connector. This one right here, that is the one I just marked with red, of course, is the LED for, or excuse me, the motor for here. M2, I'm sorry, M2 wasn't that motor. It's the motor that spins this. That was my mistake there. This one right here is your power. It even says it. And then the one directly below it should be the speaker. Speaker is the gray and red wire. And it's seated. The solder joints look okay. Pins aren't bent out of the way. I've seen it where when they push them in, the plug takes one of the pins and pushes it out of the way, so there's no connection. So just checking that. Still no sound. So we might have to open the bottom to take a look at that circuit, speaker. Because the speaker is right here, attached to the bottom. All right, let's try and open this and see if we can take a look and see if maybe one of the wires didn't break free first. Because that, for a couple of pieces, it was very common because they used a cold solder joint, so it was causing the wires to break free. Now these come straight off. As you see, I'm using my fingernail on a little tension, so I'm trying not to break. Oh, that might be part of the problem too. Break the pins. If you break the pins, a dab of super glue will fix it right up. It's not very often you have to open these. So this one's not screwed. This one is not designed to have a screw. Very, very interesting. Oh, wrong side. So where'd the screw go? I wonder if it's a bad switch. All the wires are soldered on. There's no broken connections. They all look good. So if yours breaks and you have to open it up and take a look, holding it to where you're staring at the back side, going from the first pin to the last pin, left to right, it goes gray, light blue, light green, light yellow, and white. The light blue, light green, and light yellow are your speaker. The gray and white wire is the power. That's your switch. But other than there's a cut in the power wire, there's a small one. When they pulled it tight to fit around the strain relief, I think they pulled it a little too hard. I don't see anything wrong with the switch. I'm going to check the sweep hand. Oh wait, maybe the sweep hand's broke. On the back of the switch is a little sweep hand. I have some switches. Let me grab one. I can bring it closer to the camera. Voila. So, how this works is power in, power out, that's your on-off, and then the volume control for your speaker, these 3 pins in the middle. When you rotate the wheel, which is screwed on this side, this sweep hand sweeps the volume, these 3 pins here. That's how you get your noise. And on this one, the sweep hand isn't a smooth sweep, it's actually bouncing. So I'm actually starting to wonder if maybe the inside of the switch is bad. Let me compare it to a brand new one. I'm going to put the wheel on. If I can get it to line up, like so. Yeah, this one's a lot smoother. Off and on. I don't know if you can tell, but how it works is that plastic piece pushes on a pin and click, and what it does is it lifts the contact right there. It just puts an itty bitty little gap. It's very basic, very functional too. So this one came out of a house, a parts house. Let me check its sweep hand since I know it's not new and it's used. And these might be different because they're brand new, and they might be a different manufacturer. I'm going to take one from an old Lemax house, and I want to check the sweep hand against what that one's doing. This one's a lot smoother. The reason I kept that was to try and find those, because that's got static in it. So yeah, this one's a lot harder. Let's get this other one out of here so don't accidentally use it. Can you hear the humming? I'm squeezing the switch together, and I'm getting the speaker to hum. So that's what the inside kind of looks like. Let's see if I can zoom in. That's the sweep I'm talking about. Focus. There we go. See the 2 arms? They sweep back and forth when you turn the volume, and they sweep across the copper fingers. Or, yeah, they're probably brass on this actually. And then they sweep across here as well. And different resistances give you the different volume. So now that I have that piece open, I'm going to use something non-conductive. I'm going to manipulate it. and see if that changes anything. And let's compare it to this one, because I think the sweep is broke. Focus. So the 3 fingers, those are the 3 pads it's supposed to rub against. That's the switch that has static in it. And then if I move these out of the way, notice anything different about this one? 2 of the pads are broke. So we got the solder pad here, or the contact, but these 2, the heads are missing, which means it may not be a good connection, or the indented part of this isn't making contact because it's missing the contact. So, because this is bowed down, and what that does is it contacts between the 3 pins. Well, 2 of the pins are broke. So, this might just be as simple as a defective switch, or a bad switch. So, and I'll show you this one again. 3 contact pads. Because this contact on the outer 2 isn't just for the sweep arm. Those are actually the soldered rivets right there. And the one in the middle. So these outer 2 go through this finger, the plastic, and then the copper. And then the middle one just goes through the finger and the plastic. So we'll desolder the switch. And I'll try one of these new ones. I bought them and I've never had a chance to use one, because I've always just used them from parts houses. Where's my zoom? Wrong way. Always do that. So it's very possible that this just has a bad switch. And if it's just a bad switch, we'll get that swapped out. So, goes out there. And I could try these new ones. I'm hoping these new ones are the same resistance. Because like this sweep arm, which comes from a much older house, says 10K. It's got a little, it might be, there you go, I should be able to read it. So I know it's a 10K ohm resistance. This one I kept because it's oversized. And I've been trying to match it. Because if I work on an older house that uses this, this is from one of those houses like the Village Mortician. The on-off is the wheel that sticks out the back. Kind of like also on the Crypt or the Mausoleum. It's a much bigger one, and the wheel sticks out and it turns on and off. I haven't been able to find these yet, but I did keep one. This one got hot and the contacts are black, but it does still work, surprisingly, because it hasn't damaged the internals, just the connection points. So since I have dismantled the switch, I'm just going to unplug it, like so. And I'm going to get the soldering iron fired up, and we're going to swap this switch out. So all you do is, if you don't want to screw it up, meaning you're going to forget how it goes, is have your new switch next to you, and just do one wire at a time. So you can do the white wire, goes on the far side, and then the yellow, green, blue, and gray going from right to left. So it's not terribly hard, and on a lot of my videos where I've taken switches apart, I've told you the color codes. So you can replace your switches. Most of them are the same colors. There is occasional ones where they use a darker blue and a darker green and a brilliant yellow. It's whatever wire they get at the time that's cheap. I mean, that's how everything's built, lowest bidder. So I'm going to go ahead and pause while I quickly solder this over so it's not wasting time and doesn't make this a 4-hour video. And if that fixes the sound, I'm not going to remove the bottom. And then once that's done, then we'll work on fixing the swinging pumpkin head, and I'll see about making that work. Might have to open the head because this still has no tension on it. We know there's a motor inside and a light. So I might have to pop the head off and actually take a look inside and see if the motor, if you can see it right there is the back of it, if maybe the gear broke. Because mine doesn't do this. Because when you go through a gearbox like this, you can't turn the gear. You can't go backwards. You can go forwards, or you can use the main drive to spin everything in either direction, but you can't force it backwards because the way the gearboxes work, they only work in one direction. Because of the setup with the small to big step gears, they don't work backwards. So that's why a lot of times setting up gearboxes is very time consuming. So, but let's get the grease off. So I'm going to pause it right here. I'm going to solder in a new switch. We're going to come back and test it. If that works, then we're going to continue working on this piece here. So, shall return in a few moments. All right, the switch is soldered and still is not working correctly. So the static's louder. So I'm going to have to pull the speaker assembly out. So let's turn it back off. So I'm going to start working on this piece again. Now, I looked at it closer. The reason this wouldn't come off is because I had a dab of glue in these two corners. So I remove the glue, and then this comes off. And that's how you can get this pin out of the swivel arm so you can pull the pumpkin head off. So there's the pin, and then slides right off. See on the bottom, I see a finger. Because I think this has got a screw coming in from the bottom. So I see another finger right here. And this finger has glue on it. So I'm going to try and scrape some of the excess glue off. There we go. Now let's see if I can get it to move. Alright, I'm going to use a little heat. So there's a spot here that you can pry from and it lifts right up. There's not one on this side, but if you look close, at least on this one, there's glue right in here near this finger, and this finger is still glued. And based on the way this is set, I'm thinking this is a pivot point or plastic pins because there's no movement there. So I'm going to heat up around the edges of the front and see if I can get the front to pop up so we can get inside and see why the top of this is so loose. The reason I'm not using a spudger is I don't have a spudger that small to fit in this slot. But I do have some movement. Now the glue's starting to separate, so that side's up. So now I just got to get this glue to separate onto the finger. And then these two notches slide underneath here, so you have to pop it and pull it out. And we got 3 screws. 1, 2, 3, and that screw's coming from the other direction. So two. This third screw is kind of sort of under the lip. So, and 3. Would assume that this whole base would just push out and the whole top would come off. Oh, there's another finger on the inside. I see it. See if I can get to it. Slippery. I'm not sure why it's not coming out, so I'm trying to see if I can find any clues. Those are the LEDs. Don't want to pry on those. This black isn't glued to anything. I can actually flex the orange around it. And when I do that, I can feel this top piece moving back and forth. The finger I can see through the mouth, one of these. I can disengage, but it doesn't, by just doing that, but it doesn't push out. So I'm trying to see through the eyes, if I can see anything that I can access from an eye, like a screw or a clip. Yes, there is. There's a screw. Is there any other screws? Because just taking that one screw out, this is flexing a lot. So now, is there another screw? There's got to be. Because it feels like it's caught over here. So, and there it is. Wow. So for this, if you have to take your pumpkin apart, definitely you're going to need a small screwdriver. Gotta figure out which eye has the lower cut to get to this thing. That one. So it's the left eye on the back side. And there's the other screw. There we go. Holy smokums. So the screws you can get from the bottom are the screws that hold the motor assembly together. So we're going to take that apart so I can actually get to the motor and check the pulley and stuff. So the motor is right here, and it's a direct drive motor. So there's no pulley transmission. So the motor's here, drives this little gray gear, which drives the white gear, which drives the other white gear, which then rotates the pumpkin, because this plate is attached to the top. Using this gear is pressed on. So you have to pull this gear off and then the whole thing comes out. So to change the motor, if the motor dies, you'd have to disassemble, like you see, remove the pod, take this piece off to remove the pin, then reach through the inside of the eyes and remove the two screws, which are here and here respectively, and they are on the top, and then remove the screws from the bottom, which there are 4. And then once you do that, if we pry this gear up, this should separate from the complete head. And there's the top of the head, and there's your little motor, and a couple of LEDs. And a couple of LEDs right there too. So this is pressed all the way through. So technically you could pry the top off and pull this out of the gear, but you're going to have a heck of a time putting it back in. So I would probably recommend against it. And it's got 2 little rubber pads right here as the stopper. So when it does that violent spin back and forth, it doesn't break anything. So let's give this thing some power and see if it spins. So that motor is spinning. She smells okay. Sniff test passes. I'm only setting it 3 volts. What it does is it just pulsates the motor, so it goes twunk, twunk. It doesn't send constant power to it. So this motor would fail faster, technically, because you're back and forth, back and forth, back and forth. And it's just using this short arc and the rubber pads to stop it. So, motor's good. Let's get this thing back together and work on the fixing the mechanism. And then taking the bottom apart to find out why there's no sound. Now when you press it back together, don't press it so tight that it doesn't rotate. Make sure that you have good movement. As you saw, I just press it with my fingers. It's not very hard. So let's put this cover back on. And what I said was an upside down screw is actually the shaft. So they used a screw hole style in the exposed shaft because the shaft is pressed into the gear. So the shaft turns with the gear. And all these screws are the same, so if you get them mixed up, it's not going to affect anything. good motion. Alright, so we know how to dismantle the pumpkin and check it. So that's good. And we know how the, or why this doesn't work like it's supposed to. So now we just need to get the sound and repair that. So I'm going to get this pumpkin back together. It's just a reverse. I'm just making sure I got the holes to line up for the screws. I would recommend the magnetic tip screwdriver so you can feed it through the eyeball and get those 2 screws so that it doesn't keep falling out. This can only go in one way. If you try and put it in any of the wrong ways, it will not fit because of that protruding gear and the shape of this base. So you can't screw it up. But what you want to do is make sure that when you do put it in, that the wires come out of the back and not underneath the flat like that. So make sure that you feed your wire so it comes out of the notch that they have the wire here for. So I'm going to get this back together, and then I'm going to go get some stuff so we can fix this broken standoff. I have a couple of ideas for designing it to make it function like it's supposed to, and I think either one of them will be fine. Whatever we do, we just got to make sure that it doesn't put any stress on the gear. So I'm going to get this pumpkin back together, and we're going to fix this, and then probably remove the bottom and see if it's got a bad speaker or if it's got a bad voice chip or amplifier. So be back in just a moment. Okay, the pumpkin's back together. I'm not going to lie, it's hard to get those screws back in the eyes. So it takes some time and patience. So I'm going to go over a couple of different options on how to fix this if this happens to yours, where it breaks the plastic piece from inside the hole. And then it has to, of course, slide back in. So one option is if you work with computers or electronics, they'll have standoffs where it's a round or octagonal cube that comes in different lengths with a thread on one side, or it's double hold where you have to thread it, and you can cut it to fit, but most of them are going to be too fat. So your choice at that point is to shave this down or drill that out to where this fits. The octagonal one would be useless because this has to spin, and well, it's got points. So they make them in metal. This is aluminum. This is nylon. It also is too big, but this is going to be used for something slightly different. And see, that fits. So this is a nylon bushing, so a screw slides over a screw, makes a space, so if you put a nut on the other side, whatever it is spins right here. Here is a metal bushing, which fits, and this metal bushing, which is aluminum, fits in there. Just like that. It's still too long, as you can tell. It sticks out, but you can trim it. So these are a little bit more complicated ways of fixing it, but you would basically stick this through here, drop it through the gear, have this trimmed so this is the right height, and then run a nut on the back side. So it'll go all the way through. You'd run a nut, locking nut with the nylon lock, not a one that uses a lock nut, because this can't be so tight that this doesn't rotate. So this would work. Fits inside. Fits inside. Put in the sorry, got that backwards. So this goes here, not this. So that was my bad. So all fits together. That's flush below the surface of the gear because it's a pan head. Trim that, drill this out, screw it through. The protrusion that sticks out past, you'd have to cut off, or you can get a shorter screw. But I'm not going to go this route either. I just want to give you some options. What I'm going to do is I got another small screw. And this small screw can thread into the back, because this is a through hole. And then put glue on here and then screw it down. This would be the easiest for you at your home. You may not have a bucket of parts like this that you can fabric cobble something together, but you do have options. There are many ways to fix it on something like this, because this pivot's perfect where if it does break, you can glue and screw, you can increase its strength and compress, you can go back to nylon, get a smaller one that fits inside the gear, or you can go to metal, get the cylindrical one, which even is stronger. But I would not, if possible, bore that out though, because that is your height spacer. That keeps everything aligned. So that's your height. So those are just some options. What I'm going to do is I'm going to clean this out with some alcohol. I'm going to put a bead of super glue, and I don't care if it gets in the hole. I'm going to push this back in, screw it down tight, let it cure for a few minutes, and then bam, easily done at home with nothing more than a random hobby screw. Most people have them. Worst case is when you put this back together, use a screw that isn't required or necessary. Like on the bottom here there was 4 screws, put in 3. Or if you have some old electronic stuff that you're throwing away, a lot of them, VCRs, cassette tapes, DVD players, the casings use small screws. So as long as that small screw is just big enough to fit in that hole, without boring it out too much, because you need to have some meat for the threads, and is not proud of this indentation, which is rather deep. It's about a 1/4 inch. That's the easiest way of doing it. And that's what I'm going to do. And I'm doing it this way so the average person who doesn't have the junk that I have can do this at home without spending any money. So, alcohol. I'm going to clean this surface because there is a little bit of grease, dust, dirt on here. Just to be safe, I'm going to clean this side too, because I might glue the screw head down so it won't move. Going to increase the drying by using a towel. Normally I have the brush applicator stuff, but I am out, so I have to use the standard drip method. So I'm going to put a drop or 2 across the hole. It's thick enough it doesn't go through the hole. I'm going to take this small machine screw. I already tested the fit, so I know it fits in the hole. Stick it through. Now that also just coated the threads, so it's going to act like Loctite. And then I'm going to screw this down. Ooh, the lights just flickered. We have a storm rolling in. It's kind of cool. So I might lose power. So if it abruptly stops, it means we lost power. Run the screw in, and there's, well, the top screw wobbles because it's only in a couple threads. But once it's good, like that, no wobbling, I'm going to now, let me see, the glue at the base looks good. Just make sure it's snug one last time before I glue the head down. Like that. And to prevent this from backing out, technically the glue on the threads will do it, but I am going to put a super glue bead. I'm not going to try not to stick it into the thread or the X, just around the edge. Because if you get in the X where the cross tip or Phillips goes in, you're never going to get out if you ever have to fix it again. So this is going to be the easiest way to fix this at home if this breaks off. And the only way I can see this breaking off is if this bound up or got held or manipulated wrong because of how thick this gear is. It just might have snapped it. Or it's just a defect in the casting. I don't know. Sometimes that happens. So Now it has to sit because this puddle is runny. So I'm going to try and make it somewhat level. I'm going to let it sit for a couple of minutes. There, somewhat level. So, but I wanted to show you different ways to actually make a new protrusion or standoff or lifted attachment point, whatever you want to refer to it as, with stuff. And when I take apart circuit boards for scrapping parts, if it has standoffs, I have a drawer of standoffs. Threaded, bushing style, short, long, fat, narrow. I actually have a hexagonal one like this that will fit inside this gear. But then I have the points only touching, which will wear this gear down because of the sharper surfaces. And they're brass versus aluminum or nylon. I actually have these in nylon, where it has the threads, but I didn't want to bring a nylon one because I know the torque the nylon threads would give out. Because again, these were designed to hold circuit boards. Circuit boards don't move. But as a bushing or a standoff that's made of metal, it works to replace it. And it doesn't have to be for this piece. If you have a standoff on anything, you can technically fix it. Whether you just glue and screw or replace, it's up to the spacing. If there's no spacing behind it for a nut or the screw to protrude or what have you, it might be a little harder. But something like this, if it breaks on yours, there's a few ways to fix it. Just depends on what you have lying around. And I have a lot of junk lying around, hence the name Random Junk Channel. So, but to prevent it from needing something additional, there's a way to salvage what's in here. And it's the correct spacing. So you can see the pool around the screw. It's right up to the edge at this moment. There's a little bit on the inside. So before it dries, I'm going to clean out the threads, or the teeth. There we go. And then this side, you can see hopefully you can see the shine. And it's still sticky. So I'm just going to let this sit for a little bit. And then we'll be back. We'll put this back together, glue this back on, hook the wires up, of course, and then flip her over. We'll test it first. Flip her over and remove the base. So, be back in a few once that cures. Alright, I got her back together for the most part, but the problem I'm having is the head moves, but it doesn't turn. I'm getting zero power. So I already removed the mat, and I'm now going to pull out all the stuff. So here's the speaker that's not working, and here's one of the circuit boards. This is the distribution board that sends the power to the lights from the main circuit board. And then here's the ribbon cable from the main circuit board. I'm going to see if I can get them all out. They're stuck on the glue. Like I said, the head moves back and forth, but the head doesn't spin. And when I put a meter on it, I'm getting a 0.5 volt to that motor that makes the head rotate. And that is not enough juice to make the motor go back and forth. I am actually starting to think that the main circuit board has gone out. So I heated up the mat to remove it. I got most of the mat off intact. It's right here. I didn't show that because I've shown in other videos, and if you watch any Lemax repair video, whether it be something of mine or somebody else's, usually it's a hair dryer. I use a heat gun, and then you just work your way. Sometimes they tear. This one tore the edge off. Unfortunately, it happens. But the majority of it, so I can put it back on and make it nice. When I heated up the glue, this wire right here got caught in the glue. That's the lights for right here. So that's an easy fix. I just gotta reconnect them. But my concern is the distribution board, which has an idiot light on it. I'm not getting any power up to this pumpkin, which just fell out because it's not glued in. The lights don't work and the spinning don't work, but the lights do work if I send power to it, and the motor works if I send direct power to it. which means the power from the main circuit board isn't coming out going to the distribution board. There's a break somewhere in line, and it could be a bad circuit board. It could be a bad component. It could be a broken wire. But I'm going to try and see if I can get this all out the bottom. I may not be able to. We might have to unplug this and then plug it in outside of the unit. I think that's what I'm going to have to do. Yeah, because this wire right here is so short for the motor. That's too short to let me pull it out. So I'm going to unplug this this guy as well, the other motor wire. I even reversed the motor wires, surprisingly, which you can only do for a second because the one motor just continuously spins, the other motor jerks back and forth. So this is the continuous spin motor, and that makes it go left, right, left, right. This gets a jolt, goes one, jolt backwards two. If you give this one constant power, this will just turn to one side, and it'll just keep trying to push and push and push, because it does not have micro switches like a lot of the animated Lemax pieces have, which was really surprising. I expected them to use a micro switch. They just use rubber bumpers to stop the circuit board from bouncing around. A little more simplistic, but it works. At least it's supposed to work. It's just not working on this piece. And then the drive mechanism for this guy is right here, same type of pod. It has a much different angle on the belt. It has a much smaller pulley, but it's the same belt, and it looks okay, and it works. So I know it's okay. And there is the two circuit boards side by side. So what I need to do is sit here and check the power on the components of the board to make sure that it's sending signal to this ribbon cable, which plugs in for the lights, YAR. And then I need to check to see if the part that this plugs into on the main board is getting power, because if not, one of these itty bitty little components has probably failed. And you can probably tell they're really, really small, because we got transistors, diodes, capacitors, resistors, possible MOSFETs, and then we have your speaker, amp, and then we have another known name chip, which has no numbers on it, so I don't know what that's for. I'm assuming it's probably a lighting chip to make the lights pulsate on and off as like the head turns, goes from green to purple, things like that. So testing the circuit board is a long and tedious process. If anybody's ever seen it, I've done it a couple of times where I've showed it to you. But what you do is you power up the unit, and on the circuit boards there's tracks that are a lighter green than the circuit board, and you follow the tracks from one component to the next, and then you check its power. I usually take the negative end of my meter and stick it into the negative on something I know that's negative, that has got power cycling through it. So I'll try and stick it onto the actual incoming power port. Sometimes I have a splitter that you plug the power port into, and then that splits it into the house, and then it has a leg off that I can plug the meter into as well, so I can have a constant return path to the power supply. And then I check the components and read the powers. If it's a component like a diode or a resistor and you have power on one end but no power on the other, it's potentially a bad component. So what's leading me to believe this house has an issue is I'm getting 0 volts or half a volt on the connections that these two plug into. And this plugs to the main board, and this plugs into the wire off the auxiliary board. So it's kind of odd, but I'm thinking the circuitry for the pumpkin got damaged. The pumpkin may have gotten wedged when it broke that piece off, and it overheated, because they don't use fuses or any fail-safes on these. They either work or they don't. And if they don't work, usually it's a motor that fails and it shorts out the whole unit. But in cases where they use an elaborate circuitry like this one, where you have a really large board with a lot of components soldered on it, both sides, not just the back. Your blob chip and the capacitors on the front, and then you have all the small pieces on the back, and then you have your remoted lighting board, which this is the wire for those two lights that got caught in the glue when I was heating it up and pried it. It heated the wires up and they broke. So easily fixed though. But right now that's the least of my concern. My concern is to check for voltage at each component. And if it is a bad board, that means the sound will never work. And most likely I won't be able to get the pumpkin to spin because it won't be in time to the chip, because the chip just pulses it. That's why it slams so hard when it goes left, right, left, right. It's not a soft turn or a smooth turn. I think what happened was this got wedged, the motor overheated and backfed the circuitry through the motor port, and then fried something on one of these motor connections. So it's going to be this connection here, and these chips that are off of it might have been damaged. And then the lighting, it probably is it's in sync with this. So if this has burned out a component, it's not going to send the signal to the light. So when that motor turns, it tells the light to go from green to purple and purple to green. So if this section of the circuit board got damaged because the motor died or got overheated due to being wedged, because the motor works and the motor is drawing perfect power. When I wire it separately to my voltmeter and check the amperage, she is not getting warm. I also had to disconnect it from the pumpkin, so it's not trying to turn the pumpkin against the stoppers. So I'm thinking somewhere in this upper corner of the circuit board I have a bad component. So I'm going to spend God knows how long trying to find it and see if it's going to be repairable. That's for the motor and light part. That's not even the sound part. The sound part, your sound is this chip here, I believe, if I remember right. I can't see the letters on it. Yeah, that's your sound chip. No, this is your sound chip, sorry. So then I got to check to see if something around here has been damaged to cause the sound to fail. Because I know the speaker is getting power, that's why if I touch the switch, I change the humming sound. So, and if this is getting power and it's working like it's supposed to, that means the program on the blob chip has failed and it's not sending out the audio to the amplifier chip, because this is an amplifier chip. So if the components coming off of here going through the tracks to this little chip here are still good, then this has failed. And if this has failed, it is not replaceable. You have to replace the unit or get a parts house. I have a funny feeling that this is a bad circuit board. I was able to get the motion by fixing the stud, which will help anybody that has a stud break, whether it's on this house or a different house. But playing with this off camera, so the video is not 16 days long, I have a funny feeling we have a bad circuit board. And I've already started looking for parts houses, houses that are broken, that were dropped or fell off or got smashed in shipping, that people are willing to part with for a few bucks or free or sometimes Goodwill. You'd be surprised. And I'm going to see. I'm already checking, but now I'm going to sit here and take a meter and probe the entire circuit board for the motor and all the way to the sound chip. So just to let you know where we're at on this Ghoulish Gourd. We're going to try and resurrect it as best as we can and make it as fully functional as possible. If not, I am working on a parts house acquisition right now, and if it all goes well, I should have the parts house in a week. And if it's a circuit board, I can just, this one's easy. You just unplug everything, move it to the new circuit board, plug it all back in. Poof, done. So there's not any, you don't have to desolder. A lot of the older circuit boards get wires jumping everywhere. One thing about Lemax now is they're making it a little bit easier to swap circuit boards, but they don't sell circuit boards. But what's harder is if any of these components fail, they're harder to replace. On the older circuit boards, you had physical tall resistors and transistors and capacitors. Now the only thing that's easy to remove is the smoothing capacitor, which is right there. So you got your pros and cons. as they say, these are not designed to be repaired. You break them, you throw them away. So it's one of those, yeah, you just got to deal with it. So I'm going to deal with it and see if we can fix this one. If not, we'll get a donor house and we'll get this thing back working for her. So I'll return with hopefully an answer here shortly as far as bad circuit board and we need a donor house, or fixable circuit board and we don't need a donor house. So I'm going to do some testing. It'll take a little bit of time, so I'll be back in just a few moments. All right, we're back. I got the parts house and I was able to fix it. Music. And the skull is turning and the lights are back on. We've got green, and then when it rotates it goes purple, just like it's supposed to. Turn the lights down so you can see it better. You see the color change. So, anyhow. So, I did diagnose the board. Turn the volume off, make it easier to talk. So here's the main circuit board. And your components on the back. Here's the blob chip, which feeds through right in this blank area right here. When you're looking at it from here, they're labeled for the different components. Here's the speaker. This is the speaker chip. I have good power going into the chip, but I have millivolts coming out, which is normally okay, but there's no signal going to the speaker pins. So this pin, which is pin number 5 on the chip, is no longer functioning. The chip somehow it died. I can probably find this chip and then rework a new one on here, remelt it. That's not a big deal. Like for me, if my house didn't have sound, I probably wouldn't care too much because I don't really play the sounds of my houses. But this chip is bad. That's why this one lost sound. Then, the reason I had no lights here and the top motor wouldn't spin, those plug in to here. I don't know if you can see, it's all discolored. And I'm not getting power through some of these components, which they are capacitors and resistors. These bottom 2 are resistors. These top 3 are capacitors. I have a funny feeling what happened to this house was the board got overpowered. And what I mean by that is instead of 4.5 volts, maybe somebody plugged in a 12-volt adapter. And it smoked the smaller components. But the blob chip seems to be okay. From what I can tell, going through all the different components, checking the voltages, checking the resistance and capacitance levels, everything else seems okay. I mean, technically, if I remove some of these components that got damaged and try to find a new sound chip, which they do make them, I could probably salvage this board. And I might do that later. I'm not too concerned about it now. But this, as it says here, it's the MP3-1 version 2.0 board from Lemax. The only way I can think is it got overpowered. But I don't know, because normally if you overpower a circuit board, the first thing that blows is coming in from your power, which is this one right here that I painted green, which then goes through here to that component right there, which is a resistor. That would normally be the first thing to fry. I have seen in some cases this thing pop, because this is the smoothing capacitor that smooths the noise from the motors. 2 motors right here. And the motors can handle the extra power, and even the LEDs can handle a little extra because of all the resistors that are on here to begin with. Normally what fries if you overpower is you'll smoke this chip, which that means it's totally garbage. This sometimes will pop, but normally you lose one of these smaller components in here, and usually it's right where the power comes in. In some cases, because some of these houses can technically take more power, like these motors, these are 3 to 6 volt motors. So if there was a 6 volt power cord plugged in, the motors will still do their job. But these small components that aren't rated for that 6 volts won't, and they let out the magic smoke. And I think that's why these pins, where everything is soldered are discolored because I think the power coming through got too hot and it started discoloring the board. Because here's your speaker, here is the plug for this guy, and then this is your multi-plug switch, which transfers it to the other circuit board, which controls the lights. And of course, I had no lights in this skull, which is where this plugs, or excuse me, pumpkin, which is where this plugs in at. So I have a funny feeling, however the path of electricity came through here, or it's possible that one of the components may have had a small short, although they did work if I send power to them directly. But from what I can gather is somewhere coming from this power going through there and going down to here, I lost these components. So if I go across them, I have no resistance, and I should have a resistance. If I go across these, I suppose I have capacitance. I don't have capacitance. I can try and find these little micro components, or I can just get the full-size versions and make loops and solder them on. And the other thing that probably doesn't help it any, and this could be another factor, this thing's just floating around inside here, not attached to anything. If something metallic got in here that arced a broken piece of wire when they assembled it, or it touched one of their glue joint connections where they just twist the wires together and glue it in where there's no heat shrink or protection, maybe it wore and arced it. But somehow this circuit board got damaged, and although it does function for this and the lighting, all it gives me is static because of that chip on the speaker, and it gives me no motion or internal lights here, although I was able to get the head to at least move back and forth. So the parts house was about $50 with shipping, but it gave me a circuit board to fix the one, and I now have spare parts. And what I ended up doing, even though I did fix it correctly with that screw and glue, I did replace the pod. So this has the OEM pod with the plastic pin, just like it's supposed to. So with the part house, I did end up replacing this back to OEM, so I have the screwed one that I fixed separate as an emergency backup if mine breaks, maybe. Or if somebody just needs one. You know, they broke theirs. So out of that parts house, I was able to use this and this. So unfortunately, not everything is fully repairable without a donor, and the Ghoulish Gourd is one, but we have lights and music and animation. I just got to fix the wire because apparently when I put it back together, the wire fell into view. So I got to tuck that back up inside. But yeah, it's not a huge issue. It's a lot better than when it came in. So hopefully this was somewhat informative. At least it gave you an idea how to fix your moving components if it breaks that stud, whether it be on this or another piece. You can use different ways of doing it, and you saw how I did it. And depending on your piece may vary on how you go about it. But if one of these two pumpkins fails, the motor fails, instead of taking the bottom off, you can pry out these pumpkins. Oh, and I hot glued it back in, not using super glue, in case you were wondering. The pods come out, you can unplug them, or you can fix them while they're still attached. Just be careful because this does have one shorter wire and the other ones are really long. But you can fix these two assemblies without the bottom coming off. You can even get this circuit board to come out through here so you can actually unplug this and move it away, as you saw. Same with this one. If your speaker or distribution board for all the lights needs to be accessed, then you need to remove the bottom. And when you remove the bottom, you can pull out the speaker and the distribution board, and you can pull this one out the bottom too. But hopefully you never have to do that. Be careful when you remove the bottom, because as you saw what I did before is I damaged these lights is because they had the wires in the actual glue. And that's probably just that one house. I'm sure the rest of the houses aren't that way. But that means the wire dropped when they glued the assembly together, got caught in the glue, so as I was heating the glue up and prying, it severed the wires. Not a big deal. Easily rectified. As you can see, they work. So So it isn't a huge issue if you damage a set of wires. Just make sure you put them back together in the right order. If you put them in backwards, the LEDs won't work. If you put the motor wires in backwards, it's not going to affect it too much either, because the motor just, this one reverses polarity and this one is just spins in a circle. So, but yeah, that sums up the Ghoulish Gourd. You know how to take it apart. Like I said, Happy Holiday part, no. Oh, yes. Happy Holiday Parts has like one of the gears that you may need that's in here, but that wasn't broken. But I will link to the original YouTuber that showed you how to remove the pods, because I didn't know until I saw his video when he came out. And if you have a problem with your sound and it's not the speaker or the volume switch, then you may have a blown board. And it may be this is a defect, and I haven't run mine enough to find out that I don't have the same problem, the board part. Because I don't run mine all the time. I only run it in special occasions when I turn on my display. So there's that. And I will link for the motor, pulleys, gears, and the off-on switch in the description below. Even though technically it didn't need any of that, if you need any, at least I'll link them so you can find them and maybe fix yours. And of course, that off-on switch isn't just for the Ghoulish Gourd. That's for any Lemax house that has this style switch. If you have the one that goes in the back that spins right here, it's this much larger switch, which if I take apart a house, I'll link to that one too. But at the moment, it takes this smaller switch, and I'll link it below. So hopefully this was somewhat educational for you. And this will be heading back to its owner. So I'll be putting it back in its box and shipping it back out. And of course, we're going to have a lot more videos coming. So thanks for watching. Until the next one.